Okay, sir. I just want to know the schedule, sir. Like which day, which topic will be covered.
Okay, I will share you.
Okay, sir. Okay.
Okay. In the last session, we discussed about the concept of stack. So what is the stack? See, what is stack?
Follows a particular order in which the operations are performed.
But let me repeat again.
Follows a particular order in which the operations are performed.
Actually, the stack is a linear data structure where
That
we can
for
able
sir,
to
can I
store
say, sir?
elements in a continuous memory location in a specific order.
Yes.
So what is the process of stack?
Sir, last in, first out, sir. It
First
follows.
Last in, first out. Last in, first out. So what are the last element you have inserted?
Or
That will
first
come
in,
out.
last out.
So what is the disadvantage of stack?
It will take a lot of time to remove the element.
The
And
accessing
also
of
limited
not only
memory, sir.
the accessing of element in a stack will take a lot of time as compared to the other structures.
And
What are the
random
different
access
methods?
is
What are the
Sir?
different methods in stacks?
different methods in stacks, sir.
Yeah, could you tell me? Wait.
Sir, push and pop, sir. Push and pop and
Push, pop, is null, is empty, peak are the different types of
peak.
methods.
Yes, sir.
Is full, is empty, peak, push, pop are the when we use the is full.
Sir,
when we use is full method.
is
Sir,
full.
if the size of the stack is almost full, and when we want to insert one more element, then we will check the condition is full, sir.
Okay, that is called is full. When you
Yes,
check the
sir.
is empty,
Is empty, sir. Whether the stack is exist or not, when we're defining the stack, we will check that, sir, is empty.
Very
Whether
good.
the
While
stack is
defining
empty
the
or not.
stack, we would like to set that the stack is created or not. We have to check is empty. Another case,
when pop case, sir.
whenever you
when
would like
we
to remove an element, you have
yes,
to
sir,
check whether the stack is not empty or not. If it's not empty, we can able to remove the elements from the
element.
stack.
Yes, sir.
What are the different ways to work with the stacks?
What are the different ways to?
Different ways to work with the
Work.
stacks. If you want, for example, if you would like to write a program about the stack operations, what are the different
Yes,
ways we can able to write a program?
I think in arrays, structure, and pointer and linked list, we can use this.
You can use the concept of arrays or structures,
pointers
or
or linked
pointers.
list.
There are different methods we can able to access this one.
Yes, sir.
Okay, now we'll move to the topic that is a queue. What is the queue? Queue is also the one of the data structure which will allow us to store the elements into the specific data area. So unlike stacks, generally the stack for the structure of one-ended is the structure the stack actually. In case of queue, the queue is two-side open. The two-side open means operations can be performed from both the side. So what type of operation will perform? One end is always used to insert the data. So one is from the one side you can able to insert the data, and otherwise you can able to remove the elements. So What is the insert the operation? Nothing but the NQ. NQ is the operation that we perform if you want to insert an element to the queue. You want to remove an element from the queue, you have to use the operation called DQ. So DQ is used for the method is used for the removing of data from the queue, and NQ is to use the method to insert the data into the queue. Queue is always follows the first in first out method. So what is the first in first out means? Whatever the element we have inserted in the first as a first element in the queue will be removed as a first element. So first, for example, if the queue has 10 elements, what are the first element you have inserted that will be removed first one. So this is the concept of queue. How do you represent this queue? There's example of queue representation where the data is one side, the data is inputted and it will move to here and data is along. So when you see this one, it is called one side in, one side out. So if you see that this is a data structure which contains 4 elements, and if you want to insert one more element, you have to use one side, and if you want to remove one more element, you have to remove from the other side. The place from where you have to insert the element into this nothing but called as a rear end, where from you are removing the element is called the front end. So here there are two ways, one is the front and rear. The front is nothing the position from where we are going to remove an element from the queue. The rear is nothing but the place where you are inserting a new element into the queue. The queue can also implemented in the arrays, linked list, pointers, and structures. I think the strong concept of pointers and structure you are aware in the C programming itself, and arrays also. The linked list is another topic. When you go to the next level, you can understand the arrays, linked list. So we are using now as only the arrays, the concept of arrays. If you want to use the structures also, you can use it as structure for implementation of stacks and queues also. In the previous program of stack, we are using the concept of structures also. What are the different operations can be performed in the queue is NQ and DQ. So NQ is nothing but to store an element into the queue, and DQ is nothing but to remove an element from the queue. And we can also have some methods as like a stack, like peek, inful, and isEmpty. So these are also useful to know what is the top of the element in the stack. Sorry. What is the top of element in the peek, in queue, and useful to check the queue is full or not. isEmpty to check whether the queue is empty or not. When you use the peek method, you have to use the peek method when you want to remove an element from the queue. Same way stack also. In queue, we always DQ. If you want to remove an element, sorry, if you want to insert an element, or if you want to access an element, you have to use the DQ method pointed with the front pointer. And while inquiring on the sorting, and inquiring sorting data in the queue, we take up the help of the rear pointer. So means if you want to read the data, you have to use the read pointer, rear pointer. If you want to load, if you want to use the front pointer. There are two pointers, front side and the rear side. So see here, what is the peek here? The peek is a method or function helps to see the data at the front of the queue. So it means if you want to see the data, whatever there was data available, you can use the concept of front. So that is called the peek. What is the purpose of peek? If you want to know the element of the queue. So what is the algorithm here? Generally the algorithm, what is the algorithm? Algorithm is nothing but the step-by-step process of executing the logic of a program. So what are the program you are writing the C or C++ Java? First you must write in the algorithm point. So what the purpose of algorithm means? We can able to understand the logic of the program very easily with the simple English sentences. Here's an example. We are taking a procedure. The procedure name is the peek. A return queue of front. So the queue of front is nothing but we are looking for the element. So we say what is the peek means nothing but the first element which you have inserted into the queue is nothing but the peek element. See here, int peek return queue of front. So the method to implementation of peek in the C programming language or C++ also. So here the useful method basically use it to know whether the stack is full or not. When we just use this case is whenever you want to insert a new element into the queue, you must have to check the queue is full or not. So this is a algorithm for to check whether it's full or not. And the next one is the NQ operations. The purpose of NQ operation is nothing but to remove an element from the stack. See here, Q maintains two data pointers. One is the front pointer and the rear pointer. Therefore, its operations are comparatively difficult to implement that of the stack. See here, first what you have to do, first check if the stack is full or not. If you want to if you want to NQ an operation, NQ means if you want to insert an element to the queue, first you have to check that whether the queue is full or not. If the queue is full, it says that we can't able to insert a new element. If the queue is full, produce overflow error or exit. So it means there is no possibility of inserting the new element if the queue is full. Then your third step is if the queue is not full, means that there is a possibility of inserting a new element into the queue. Increment the rear pointer to point to the next empty space. So see this logic here. So see, this is the simple data structure. Here contains three elements A, B, C. So here A will call as a front pointer and C will call a rear pointer. As we said, the NQ is always performed from the rear side, not from the front side. So I would like to insert a new element D here. Then what I do? I have to change the rear position of from C to the a new pointer place. For example, the index number here is the front for the 0, we have A is 0, here B is 1 and C is 2. As we discussed, the array indexes start from 0 to n-1. So the index of A is 0, index of B is 1, index of C is 2. If you want to insert an element, you have to insert one location. That's why we have to use one more block here. The block is nothing but the block 3. So 0, 1, 2, 3. Now we are placing the element D into the 3 position. So when you place the element D into the 3 position, automatically the rear is shifted from C to the D pointer. So now see, the rear automatically becomes a D and front is as usual. This is the operation of NQ. So as we said that there are two operations, NQ and DQ. NQ is for the purpose of inserting a new element into the queue, and DQ is easy to remove an element from the queue. If you want to insert an element to the queue, first you have to check whether the queue is full or not. The queue is full, you have to get a display that it is overflow of queue and you have to exit the program. If the queue is not full, there is a possibility of inserting an element into the queue. Then what you have to do, we have to increment the position of the rear. According to the example here, the rear position is 2 and we will increment the position of rear by 1. That is called 3. Now the block 3 is vacant and this block is filled with the new element D. Automatically the rear will become as 3 instead of 2. This is a way that we will insert an element into the queue. This is algorithm for NQ operation. So here, NQ operation of data. So data is nothing but what is the value you want to insert here. That is a parameter to the NQ function. The queue is full, return overflow. And if that's the end of the matter. If you see, otherwise means the queue is not full. Then we have to change the rear pointer to the rear +1. Now queue of rear. So queue of rear means the queue of rear. So what is the earlier rear position? 0, 1, 2. And it shifted to +1. The rear means 3. Now queue of 3 means what is the empty block we have. That is filled with the data. So what is the data we are using there? Number, for example, 3 D. The D will be placed with the new area. Return the true. This is a procedure to insert an element to the queue. The simple logic here is, if you want to insert an element into the queue, you have to change the position of the rear. How do you change? You have to increment the rear position by 1. Then automatically one block will be created and the block will be successfully filled with the new element. Next one, the DQ operation. And nothing but to pop up the element from the queue. If you want to pop the element from the queue, first we have to check the queue is empty or not. Because the queue is empty, there is no point of removing an element from the queue. So if the queue is empty, produce underflow. So underflow means there is no elements. There is no element means there is no possibility of removing an element from the queue. If the queue is not empty, then what you have to do? We have to access the data from the front pointer. So now we have to use the front pointer, not the rear pointer. So what we will do? Increment front pointer to the point to the next level of the data element. Next element of the data element and return success. So say this one. Here example, after insert the previous case, NP operation we have A as a front and D as the rear. Now see, I'm removing the element A. So whenever you change the pointer, see, earlier the index number is 0. We are increasing the index number to +1. So it will become as 1. So automatically it shifted to here, the front from A to shifted to B. So whenever shifted to B, automatically the element will be popped from the DQ. So this is the way. So in the C, both the cases, there we are incremented the rear side. When the NP operation perform, the DQ is operation perform, we are increment the front side. So DQ operation, we have to increment the index number of the front side, and NP operation, we have to increment the index number of the rear side. So this is the way you can able to remove the elements from the stacks and queue. So now what is the algorithm for the DQ? First, what you have to check? If queue is empty, then we have to say it's underflow because there is no possibility of removing element from the queue because no more element exists in the queue. If the element is there, then what you have to do? Data equal to queue of friend. So whatever the element you are trying to remove, that element will be placed in the data variable. Now front equal to front +1. So what we are doing here? We are placing the data, we are placing the front value, first value to the data variable and increasing the front index number. So when you increase the front index number, automatically B will come into the position of A and C will come into the position of B and D will come into the position of C. So this is a procedure for DQ operations. This is a simple example of implementation of queue in data structures. Using C++. The first what you are doing here, first we are define the size here. The size means how many elements can be inserted in the queue. I'm taking an example of 5. So here we are using the concept of classes. So what is the concept of class? We are already about the object-oriented programming concept. That what is the class? Class is one of the data type. It's a user-defined data type that is used to construct the data. So it means different kinds of variables can be integrated at one place. See here, so many non-primitive data types can be combined and make it as a primitive data type. Sorry, so many primitive data are combined together and make it as a non-primitive data type. Your class is a non-primitive data type. What is a non-primitive data type? It means nothing but the data type which can be able to create our own. For example, structures, unions, queues, classes. These are nothing but concept of strings, the point of arrays. These are all the concept of non-primitive data types. So see the example. First I am creating the class queue, the data of a queue, an array, my queue with the size 5 and front and rear. So this statement will declare an array with size 5 and a front variable and rear variable. Here the front variable is used to DQ the element and rear variable is used to NQ the element. So now in the main method, in the function, in the public function side, as we know that the class contains the data and functions. In the function side, I'm using the method called queue. I think you people are aware about the C++ program. Can you say anyone that what is this one? If the class name is same as the method name, what we can say? Any one of you people aware of the classes in C++? The class name and the method name. See, the class name is Q and the method name is Q. What we say that one? Any one of you? Do you people aware of the classes or not?
Yes, sir. Yes, sir.
Tell me. So if the class name and the method name are same, then what you say?
If class name and method name are same, then I think it's private, sir.
Any of the rest of you? Whenever a method name and the class name are said, we can call it a constructor.
Yes, sir.
This method here, this method Q will be called as the constructor method. In the case whenever the class name and the method name are same, you can say it is a constructor. What is the purpose of constructors? Any one of you, don't idea? Why we use the methods?
To create the instance of the class, sir, there are almost
Create instance for the class means we can. How can you create the instance? Example class
to
name.
construct an object and assign values to the object members, we have to construct the constructor, sir. A constructor.
See, what is the purpose of constructor is to initialize the objects.
Yes, sir.
The main idea of creating the constructor is automatic initialization of objects.
Yes, sir.
Whenever you create the constructor, it will automatically invoke.
Yes, sir.
There is no need to call the constructors. The constructors will automatically invoke. The constructor is similar. Constructor is a method which is similar to the normal method in a class, but it has the same name as the class name. The advantage of constructor is they are used to initialize the objects. Constructors are three types: default constructors, parameterized constructors, and copy constructors. Default constructor means the constructor which doesn't have the parameters is called the default. See an example here. Here Q is a constructor which doesn't have any parameter. See, you don't specify between the parentheses. When you don't specify that between the parentheses, we can say it is a default constructor. To say Q of int A, comma int B, we can say the parameterized constructor. The constructors can be parameterized or non-parameterized or copy constructors. For this example, indicates that is a constructor without any parameters. What the purpose of here the constructor is to initialize the variables. What we are doing here, the help of this constructor, we are initializing the values here. The data, what is the values here? Front and rear variables. We are initializing the front and rear variables with -1. Why we have to need to take the -1? In the stack, we have explained the concept. Why we need to take the -1? What is top of the stack equal to -1? Why? Why the top of the stack equal to -1 first?
Because
If you
the
say
index of the array starts with 0, sir.
The index is start from 0. If you say the front equal to 0 or rear equal to 0, it means at least one element is there. If you want to create an empty queue, or if you want to create an empty stack, we have to say top of the stack equal to -1. You want to create an empty queue, you have to say front equal to -1, rear equal to -1. When you say that front equal to -1 and rear equal to -1, it says that there are no elements in the queue. It's an empty queue. So next one, bool full. This is a method to check whether the stack is full or not. How do you check? If front equal to 0 and rear equal to maximum of size -1. If the front equal to 0 and rear equal to maximum of and what is the maximum here? 5. 5 minus 1, 4. So front equal to 0 and rear equal to 5. అంటే అర్థం ఏంటి? We said the size equal to 5 mm. Okay, we are saying here if front equal to 0 and rear equal to size minus 1. Then what side minus 1 size equal to minus 1 means 4. So front equal to 0 and rear equal to 4 అంటే అర్థం ఏంటి?
Full line
Huh?
answer. Right.
There is no chance of element inserting because front equal to 0, rear equal to 4 అంటే అన్ని ఎలిమెంట్స్ ఆక్యుపై అయిపోయింది, అక్కడ ప్లేస్ లేదు.
Yes, sir.
That is say boolean is full. Is full. Okay. Next one is empty. How do you check now? If front equal to minus 1 అంటే అర్థం ఏంటి?
There is no elements.
There is no element. The empty stack is empty.
Yes,
There
sir.
is no stack. If the stack is empty, there is no point of removing the elements. Now, so here how many functions are there? First one is the Q function. This is the constructor function to initialize the front and rear values. The second one, bool is full function to check is the Q is full or not. The third one, bool is empty, which is used to check is there any possibility of having elements or not. Next one, come to the important one, the NQ operation. The NQ operation, if you want to NQ, you must have to pass a value. Here the int value means the value is a variable which will be passed as a parameter to the NQ function. What we'll do now, when you pass the parameter, first you will check if is full. So means if is full means if the stack is full. The stack is full, what it means? There is no possibility. That means the queue is full. Else the queue is not full. Then what you have to do? You have to check if front equal to minus 1. If front equal to minus 1 అంటే అర్థం ఏంటి? There are no elements. Then we say the front equal to 0. Means we are creating an empty space. See, if the queue is full, we say the queue is full. If not full, we check whether the whether the front equal to minus 1. అంటే ఒకవేళ ఖాళీగా లేదంటున్నావు, బట్ ఇట్ ఈస్ ఎంటీనా పోనీ అడుగుతున్నాం. ఒకవేళ ఎంటీ అయితే ఏం చెబుతున్నాం? ఫ్రంట్ ఈక్వల్ టు 0 అంటున్నాం. రేర్ ఈక్వల్ టు ప్లస్ అంటున్నాం. అంటే ఫ్రంట్ ఈక్వల్ టు 0, రేర్ ఎంత? -1. సో ఫ్రంట్ ఈక్వల్ టు 0 అయింది, రేర్ ఈక్వల్ టు కూడా 0 అయింది. సో ఫ్రంట్ ఈక్వల్ టు 0, రేర్ ఈక్వల్ టు 0 అంటే అర్థం ఏంటి? ఒక బ్లాక్ క్రియేట్ అయింది. సో ఈ బ్లాక్ లో నేనేం చేస్తాను? మై క్యూ ఆఫ్ రేర్ ఈక్వల్ టు వాల్యూ అన్నా. ఆటోమేటిక్ గా వెనక నుంచి వెళ్ళేసి ఒక వాల్యూ దానిలో స్టోర్ అయిపోతుంది. ఏ వాల్యూ స్టోర్ అవుతుంది? వాట్ ఎవర్ ద వాల్యూ ఐఎమ్ పాసింగ్ హియర్. సింపుల్ లాజిక్. యాజ్ వి డిస్కస్డ్, if the queue is empty, the queue is full, there is no possibility. The queue is not full, then I will check if the queue is equal to the means front equal to -1. But the front equal to -1 means then empty queue. Then if the empty queue, you have to create the space. That's why you have to increase the front value and also increase the rear value. A location will be created and you have to insert into the element. So this is the way. This is the way this completely follows. Next one, DQ. If you want to DQ the element, there is no need to specify the num value because there is no point of removing the specific value. There is no point of removing the specific value. When you use the DQ, automatically whatever the element at the front side. Hello? Hello? When is the DQ operation, here whatever the element at the front side will be removed automatically. So there is no point of sending the parameters to the DQ. For inserting, we need to send the parameter. For DQ, there is no need to send the parameter because automatically the front element will be removed. Okay. So you say int value, if E is empty, So E is empty means if the queue is empty, there is no point of removing the element. The queue is not empty, then what you have to do? You have to say front equal to minus, rear equal to minus. What will happen? We are decreasing the locations here. Front equal to minus, rear equal to minus. Automatically, yes, means if it is not empty, then what you have to do? Front plus plus. Front plus plus means we are increasing the index number of the front. Earlier the index number is 0 as per the NQ operation. Now it will become as 1. So when it is become as 1, automatically 0 element will be removed. So Cout deleted equal to value. So whatever the value you are deleted from the stack, so this is the return value. So this is the way we can able to remove the element from the stack. Next one, display. Display method is to display the elements after or before inserting or unqueuing or dequeuing the elements. See here, we are taking if E is empty queue is empty, else I'm displaying the front element, I'm displaying the queue elements. What is the display the queue element? I equal to front. The front is means I equal to front means the front value is initially 0. I equal to front, I less than or equal to rear, I plus plus. My Q of I. So my Q of I means the front element first, next element, next element, next element till the last element. So and the same way rear. So here what is output here? This when you use the display function, it will display the front. What is the front element and what is the last element and what are the total elements? So this is a program. The different functions. The first function is to check. First function is to initialize the object, and second function is used to check the full or not. Third function is to check is empty or not. Fourth one is to insert an element like NQ operation, and fifth one DQ operation, and finally display queue operations. Now the main method. In the main method, here what is the sentence here? Queue my queue means we are creating an object. We are creating an object for the class queue. The object name is myQueue. So here with the help of the object myQueue, I am accessing the methods that are available in the class queue class. So what are the methods? There are different methods: is full, is not full, is full, is not full, or display. There are so many methods, NQ, DQ. So from there I am using the operation DQ. So what I am telling is I am removing the element. Next. Cout queue created. Now it is the operation about the NQs. So we are inserting 4 elements, 10, 20, 30, 40. So ultimately the 10 will become as the first element to exit. So whenever you use a DQ operation, the first element removed is the 10 element only. So in case of stack, what is the first remove element? 40. So here my NQ is 50. So totally I have inserted 6 element. After that one, I am using the display queue. After that, I am using the DQ. So when you use the DQ operation, automatically which element? It removes the element 10, because as per the logic, the first element have to go first. So why instead the first element 10, 20, 30, 40, 50, 60, automatically 10 will come out. After that, we are displaying this is the program. So first it will get a message queue is empty. Now this queue is created. We are inserting the elements 10, 20, 30, 40, 50. Now we say the queue is full because there is no possibility of insert the element. Now the front equal 0. Here queue elements are 10, 20, 30, 40, 50, and rear equal to 4. So means that what is the index number of front and index number of rear? As we said, the index number starts from 0 to n-1. The maximum size is 5. That's why 0 to 4. Here deleted element is 10. So because here now whenever you delete the element, automatically the index number 0 will be removed. So then automatically 1 to 4 is the new index numbers, because the 0 to 4 is already removed. Now the elements are 20, 30, 40, 50. don't see this way. You have to see elements in the reverse order generally, as per the logic. Because now at this point of time, we have to say this is the front and this is the rear. In the logic of the designing of the program, when you have the picture representation, nothing but front is at this side and rear is this side. But display point of view, front is this one and rear is this one. Okay. If you want to display correctly, you have to use the reverse order. So how to use the reverse order? You have to reverse the for loop like here. So here you say the for loop I equal to front, right? Now you have to use the I equal to rear. I equal to rear, I greater than equal to front, and I minus 1. Then you can get the exact position. The output will be then the output will become as 50, 40, 30, 20, 10, and 50, 40, 30, 20. So these are the operations of queues. So this is about the total class of today. So this is completely related to the concept of how to create a queue and how to insert the elements. As you say, the queue is a data structure which we can able to insert the elements. The queue follows the FIFO, first in, first out. The elements are inserted from the rear side and the removed from the front side. Here, we to insert the element, we use the NQ operation. To remove the element, we use the DQ operations. What are the different operations we can perform? Is full, is empty, DQ, NQ. So when you generally, if you want to use, you can use the arrays, you can use the structures, you can use the pointer.